Okay, so it is in recording now.
Perfect.
So what are the magnitude of the drag force at 70 kilometer and 100 kilometer? We have two speeds. One is a 70 kilometer and other is a 100 kilometer. And also we have two types of the vehicles. One is a Toyota and other is a Hummer H2. These are two vehicles. So information of the first vehicle are having the area 0.7 meters square and its drag force constant is 0.28. Similarly, for the second vehicle, we have an area 2.44 meters square and its drag force constant is 0.64. In the both cases for the different velocities, we have to measure the drag force. But for before measuring the drag force, we need to understand the formula for the drag force. We have Fd is equal to 1 by 2 rho 1 by 2 rho A. Rho is actually the density, A is the area, and CD is actually the drag force constant, and V square is the velocity with which one of these vehicles is traveling. So first of all, let us observe a problem. All the units are same or not. As you can see here, units are kilometer per hour, and we need to convert these units to meter per hour. And also, for example, for 70 kilometer per hour, if we want to convert it into meter per second, what you need to do, 1 kilometer is equal to 1000 of the meters. So multiply the upper values with the 1000, and 1 hour is equal to 3600 seconds. So divide it by 3600, then we have the velocity in meter per second, that is 19.44 meter per second.
I will quickly
In
now
a-
grab the food so it doesn't burn. Sorry.
okay, it's okay, it's okay.
Thank you so much for waiting.
Okay. So let us resume the lecture. In
Mhm.
any problem of the physics, before solving, you need to make sure that all the units are actually the SI units. If they are not SI units, for example, some bigger units, then you first need to convert those units in a proper unit. For example, as we have here kilometer per hour, and we have converted 70 kilometer per hour into the meter per second, that is 19.44 meter per second, and you can consider it is actually our first velocity. And similarly, you can convert the second velocity. Second is 100 kilometer per hour. And as we will convert, we need to proceed like the same procedure. 100 multiplied by the 1000 divided by the 3600. And finally, we will have a result for the second velocity in meter per second, 27.78 meter per second. So now we have two velocities in meter per second. And what we have to do, we have two types of the vehicles. One is a Toyota, other is a Hummer, and we need to apply these both velocities, and for these both velocities, one by one we need to measure the drag force for each vehicles. For example, drag force of the Toyota at first velocity v1, drag force of the Toyota at second velocity v2. Similarly, drag force of the Hummer at v1 first velocity, and drag force of the Hummer at velocity v2. So the formula for the drag force I have shown here, Fd is equal to 1 by 2 rho AV ACD square, and here rho is actually the density of the air, that is actually the constant, and for that purpose we use rho as a 1.2 kilogram per meter cube. Yes. It is actually air density because a vehicle is traveling through the air, then the drag force of the air will oppose the direction of motion of the vehicle. So its rho is the drag force, the air density. And another thing for the first vehicle, the area of the wheels, that is here 0.7 meter per square. So you can say A1 is equal to, as we are talking about the first vehicle, 0.7 meter square, and its drag force constant for the first vehicle. You can consider it as a CD1 because we are talking about the Toyota. So it is 0.28. As it is a constant, it is a unit less quantity. And in the formula, we have the density. Yes, we have the density. Here it is given. We have the area. Yes, we have the area. Here it is given. We have the drag force constant. Yes, we have drag force constant. That is 0.28. And also we have the velocity, that is V1 and V2. So by using the formula, we need to measure the drag force force for the both cases. For example, for first velocity V1, we are bearing the drag force. So let us replace the values 1 by 2 multiplied by density is 1.2 multiplied by area is 0.7 multiplied by CD is a constant, that is 0.28. Here it is given 0.28. And last factor is actually the velocity. And as we are using first velocity, so we need to write here for V1. Okay, so let's write the velocity V1, that is given here 19.44. As here the factor of velocity is in square, so we need to write it 19.44 square. Okay, so its final result that we can have is equal to 44.44 Newton. 44.44 Newton. So it is the drag force of the Toyota vehicle, and that is traveling with the velocity v1, which is 19.44 square. So FD for the first vehicle Toyota is FD1 44.449 44 Newton. And now we need to repeat the procedure same for the second velocity for the first vehicle for V2. So what we need to do, we need to replace the same values, just we need to change the value of the velocity here. Then our equation will become is equal to 1 by 2 multiplied by 1.2 multiplied by 0.7 multiplied by uh, 0.28 multiplied by second velocity, which is equal to, here you can see, yes, 27.78 second velocity multiplied by square of second velocity 27.78 whole square. And as a result, you will have the drag force for the second velocity as a FD2 result is equal to 91 Newton. 91 Newton. And this was actually the first part of our problem in which we have found the drag force to at two different velocities for the Toyota vehicle. And now we need to repeat the same procedure for the second vehicle, that is Hummer. And for that purpose, the values are actually different. So I think I need to rewrite these values. For the second, we have the area A is equal to 2.44 meter square, and its drag force constant CD is equal to 0.64 and remaining things are actually the same because air constant, density of the air rho is 1.2 kg per meters cube, and we will use the same and same formula. So FD is equal to, just what we need to do, we need to or put the values in the formula of the drag force that is given here. In this formula, we will need to replace the corresponding values. So 1 by 2 multiplied by 1.2, which is a density, multiplied by CD, which is a 0.64, multiplied by area, which is 2.44, multiplied by first velocity V1, that is 19.44. So multiplied by 19.44 square. And as a result, final answer of the second vehicle for the first velocity V1 is 354 Newton. 354 Newton. And for the second velocity, we need to also repeat the same procedure. You can say FD1, FDH1 because we are talking about the hammer. So H1. Similarly, here FDH2. What we need to do in this case, we need to write the same values. Just we need to change the velocity. So 1 by 2 multiplied by 1.2 multiplied by 0.64 multiplied by 2.44 multiplied by second velocity, that was 27.78. 27.78, as in the formula of the drag force there is a square of the velocity, so we are squaring, and finally we have the answer for FDH2. FDH2 as to 723 Newton. So it was very simple problem. Data was given to us. What we have to measure, we need to measure the drag forces at different velocities for two different vehicles having the different facing area, having the different drag force constant. Is it clear? Is it clear?
Oh, sorry. Yes, it's clear.
Okay, I want you should have a look on the solution here. Clearly, notes are written. If you will have any difficulty, you can ask later.
Mm-hmm.
Okay, so frontal area of the first vehicle, as we are talking about the Toyota frontal area and its drag force coefficient. Similarly, for the Hummer H2, frontal area and drag force constant is equal to, and air density is given, which is a constant. And here we are converting the corresponding velocities into meter per second, and two velocities are converted into meter per second. You can say it is a V1, and second it is a V2. And for the first velocity, we are working for the Twitter first curve, half rho A C D V square, and putting the corresponding values and multiplying and simplifying drag force for the first case. Similarly, for velocity V is equal to 27.78 meter per second. FD is equal to 1 by 2 multiplied by rho multiplied by A multiplied by CD multiplied by V square. And simplifying, putting the second velocity in square factor, and we have the relation 90.75, and after rounding it off, it has become 91 Newton. Now we are here to find the same values of the drag force for the second vehicle. So V1 is equal to 19.44. Same procedure, just you need to put the value of the V and find out its result for the drag force. Similarly, second velocity, putting the value of the second velocity and result for the drag force for the second velocity. So here we have found the relation for the drag force for the four cases. Velocity V1, V2 for the first vehicle, velocity V1, V2 for the second vehicle. I hope it is clear to you.
Yes, it's clear.
Okay.
Yes.
Okay, let us move towards the second next question. But before that, I need to clear the area on which I am working to have a space to solve the question. Okay. Okay, let us work on the second question. By what factor does the drag force on a car increases as it is goes from 65 to 110 kilometer per hour? Here two velocities are given and we need to find the drag force factor that is changing with respect to each. But before that, we need to again rewrite the drag force formula to check that on which factor drag force is actually depending. Half rho A C D V square. These are actually factor. And from the statement, by what factor does the drag force on a car increases as it goes from 65 to 110 kilometer per second? As we are talking about the same car, it means same car, same air density, same drag force constant. These are not changing. But in the statement, the only thing that is getting vary is actually the velocity. And from the relation, you can see drag force is actually directly proportional to the square of velocity, while the other whole things are constants. So, first of all, we need to write an equation for each speed. For first speed 65, our relation will become fd1 is equal to 1 by 2 rho a cd v square is actually 65 square. Similarly, for the second velocity, we need to say it is actually fd2 is equal to 1 by 2 rho a cd and second velocity square that is actually 110 kilometer. What we need to do as we are finding a factor with which the drag force is getting increased, then we need to say we need to divide fd2 should be divided by fd1, or you can say second equation should be divided by first equation. Then our equation will become fd2 divided by fd1 is equal to 110 divided by 65 whole square. So what we have done here, you can see this factor is similar in the both cases. As a result of division, it will be cancelled. The only remaining value will be 110 over 65 that we have written. As both are in square form, so we have written them in a single square 110 over 65, which will results the value 2.864. 2.864. So it is clear that whenever speed will increase from 65 to 110, then our drag force that was initially F1D will be increased by a factor that is 2.864. By this factor, drag force with the increase in speed will increase. Is it clear?
Yes, it's very clear.
Okay, now you need to also have again a look so that everything should be clear in this lecture. So here car speed increases from 65. It is actually the statement and the drag force formula. As here all the other factors are constant, only speed is get varied and also we know. So speed is directly proportional to the square of velocity. Putting the values, dividing the equation 2 by equation 1, simplifying, it will be cancelled out. The only result is 110 over 65 square and simplifying. Finally, we have the factor with which drag force will increase. So let us check the question next. That is question number 3. A terminal velocity of a person falling in air depend upon the weight. Terminal velocity depend on the weight and the area of the person facing the fluid. Fluid mean as the person is falling, so the fluid about which we are talking is actually the air. Find the terminal velocity. Okay, we have to find the terminal velocity in meter per second first and then kilometer per hour second. Of an 80 kg skydiver is falling in a head first position. He is moving downward and with head first position. With surface area of his surface area of his head 0.140 meters square, and drag force constant is CD 0.7. So we need to measure here the terminal velocity, but to measure the terminal velocity, we need to know about its formula. So its formula is Vt is equal to 2 mg divided by rho A CD. Rho A CD is actually the area, rho is the density of the air, CD is the drag force constant. So we need to put the values that is given to us in this statement. 2 multiplied by, as the weight mass of the person is 80, so m is 80, multiplied by g, you know, is 9.8, divided by rho is actually air density 1.2, multiplied by A is the area, that is 0.140. Here you can see 0.140, multiplied by the next factor is CD, that is 0.7, and as a result, by using the calculator, you can have the relation for the terminal velocity, that is 115.5 meter per second. That is the relation for the terminal velocity. But as he is saying, you need to find it or convert it into the kilometer per hour. So for that purpose, what you need to do, you need to multiply it, because 1 meter per second already we know is equal to 3.6 kilometer per hour. So what you need to do, just replace this meter per second by 3.6 kilometer per hour. Then our equation will become 115.5 multiplied by 3.6 kilometer per hour. So as a result of multiplication, we have the value that is 415.8 kilometer per hour. So we have calculated the terminal velocity according to the given condition, first in meter per second and then in kilometer per hour. So you need to check it here. Mass, area, drag force constant, and air density and gravity. Formula, just you need to replace the values and calculate the result. 115.5 meter per second, and as a result multiplied by 3.6. Finally, you have calculated in kilometer per hour and also in meter per second. Is it clear?
Yes, it's very clear.
Okay. So here next we have a question number 4. A tennis ball is hit at 200 km per hour. The drag force of the magnitude Fd is directly after the hit can be characterized thanks to the following quantity. Okay, here we are talking about a tennis ball that is hidden and moving with the velocity 200 km per hour. And we need to choose option from the following so which will be correct? The drag force is very less than weight. First option, drag force is just less than weight. Second option, drag force is greater than weight. Third option, drag force is very greater than the weight. It is actually the fourth option. So something is here in the statement. Estimate the order of the magnitude of the quantities at the play. A tricky quantity to estimate is the density of the air. Precise value, that is a constant value. Try not to use the calculator. After your computation, use the internet to perform a metrology check with the actual number. So first of all, we need to check as just by considering some values, and after that we need to check the internet values and verify the results are same or not that we can calculate in our first case. So from first, as he is talking about the tennis ball, and he is also talking about the drag force. For the drag force, we have the formula Fd is equal to 1 by 2 rho a CD, drag was constant, we scare. But in our current case, he is only providing us the velocity. He is not providing us the air density. We can consider it as a constant, but he is not providing us the area. He is not providing us the drag force constant CD. So for calculation, initially, we need to consider some values. So we are considering its area is equal to pi r square. R is actually a radius. Radius is equal to the half of the diameter. So as we will place here the value of the diameter, then it will become pi d square by 4. So its diameter that we are considering is equal to 0.1 k. Yes, 0.1 m, and its mass that we are considering m is equal to 0.1 kg, and its drag force constant that we are considering CD is equal to 0.6, and velocity that is also given to us is v is equal to 200, but we are converting it into the meter per second. That will become 55.56 meter per second. That is actually its velocity. So we have almost all the values. So what we need to do, we need to replace all the values
Sorry,
in this equation.
I got a little bit confused with how we got to the 0.1s for the other values.
These are actually, we can suppose these values, just we are talking about the drag force to calculate the drag force, and we are talking about the tennis ball. So we are considering the weight of the tennis ball is 100 of the gram, and just we by converting into the kilogram, that is 0.1 kilogram.
So we're
And
just
we are
guessing.
actually, yes.
Ah, okay. Makes sense.
Okay. Okay, because whatever we will use the values, we will calculate the drag force. We need to choose the following quantities, because as we are considering here the mass too, we also compare the drag force and weight, because it is totally topic of the fluid dynamics, in which we talk about the terminal velocity. Terminal velocity is a constant velocity that is achieved when drag force acting on the body become equal to its weight. That is actually the constant velocity. So
Mhm.
here is actually the comparison of the drag force and the weight. So first of all, we are calculating the drag force by putting the values in the above formula. Our drag force will become Ft is equal to 1 by 2 multiplied by 1.2, which is air density, multiplied by uh, next is CD 0.6 multiplied by area. If we want to calculate the area, then we have considered its diameter is 0.1. You need to put that diameter in this equation, pi into 0.1 square divided by 4. That will results the area will be equal to 0.0078. 0.0078. 0.078. It is actually the area of that tennis ball. So put here the area 0.0078 multiplied by the speed, that is 55.56, 55.56 square. As a result, we have the drag force relation FD, that is equal to 8.668 Newton. 8.668 Newton. And now we need to calculate its weight. W is equal to mg. Masses that is here considered is 0.1 kg. So is equal to 0.1 multiplied by 9.8, which will result the value 0.98, 0.98 is equal to 0.98. So we can see the value of the drag force is 8.66 Newton and value of the weight is 0.98 Newton. So we can see drag force is actually greater than the weight. So here is an option, drag force is greater than the weight. Third C option, drag force is greater than the weight. It was actually the first part of the question, but we need to also check it on the second part. What is second part? We need to perform a metrology check with the actual number by using the internet. So from the internet, the values that I have found, and also these are actually the part of your this module, you can check at the end. Masses that is considered here for the tennis ball, actually these values we will use to verify our results that we have done in our previous case. 0.56 kg is the mass of tennis ball and its diameter is 0.064, 0.0654 meters square, as we are talking about the area. And the next is area, sorry, it was a diameter, it is be only meter, and its area is A is equal to 0.00336, 0.00336. And by using these values, and we can calculate the drag force. So after the calculation by using these values, by the formula of the drag force, we have the results for the drag force, that is 3.373 Newton. And as here the weight mass is 0.056 kg, then from this value we can calculate the weight 0.056 multiplied by 9.8, and that will results the weight is 0.55 Newton. So it is actually the verification of our previous result, because you can see here weight is again less than the drag force constant. So option 3 is correct, which is drag force is greater than the weight. I want you need to have a check here.
Okay.
Okay. So here is a considered data for the tennis ball. Tennis ball is of 100 gram, that is converted into a kilogram, 0.1 kg, and diameter 0.1 meter, and its drag force coefficient 0.6, and rho air density, that is a constant. Velocity is the only factor that is given to us. We have converted it into the meter per second, and by using the drag force formula, we need to calculate its drag force, that is 8.668 Newton, and weight is W is equal to mg, that is 0.1 multiplied by 9.8, and finally it is FD is greater than mg. Option 3 is correct, but the values from the internet, and these are actually the values from, by using these values we have found the drag force, that is 3.73 Newton, and its weight is 0.55 Newton. And again, it is an evidence, or you can say it is a proof that third option is correct. FD is greater than mg. Is it clear?
Yes, it's very clear.